Well, hello, ladies and gentlemen. We are going to look at something a little bit different today. By different, I mean something like this. Say we want to know what is the measure of arc SU. The M would be read as measure, as in what is the measure in degrees. That curve above the SU would be arc, and SU would stand for the letters SU, of course. So what is the measure in degrees of arc SU? And that would be located right here. How many degrees is SU? Okay. Of course, if you went all the way around the circle, right, all the way starting at S and made your way on back to S, it would be 360 degrees, 360 all the way around. But how many degrees is it from S to U? What is the measure of that arc? Well, this is how we do that. But first, just a couple of words on this concept of arcs. Look, from the 3 hour to the 12 hour, right? From 3 to 12 on a clock, that would be 90 degrees of arc, right? Note also where the hour hand and the minute hand meet up when it's exactly 3 o'clock, there's 90 degrees. If the arc is 90 degrees, the central angle is 90 degrees and vice versa. That's always true. The central angle is simply the angle whose vertex is at the center of the circle. That's true for a clock. Consider a pizza. Imagine a pizza were a perfect circle. Imagine we're cut into 8 slices, all of them being the same size, right? One slice, 360 divided by 8. One slice would have a central angle here of 45 degrees. And the arc, the crust, would also be 45 degrees of crust. So I think that clarifies or gives some familiar examples of what an arc is and what a central angle is. Clock, hands on the clock where they meet, that's the central angle. From 3 to 12, that's the arc. The crust of the pizza, the slice of pizza, that would be an arc. The tip of the slice, that would be the central angle, et cetera, et cetera. Okay, so now how do we do this? What is the measure of arc SU in degrees? Well, we just take the, we take the fact that a circle has 360 degrees, and we're going to use that. The measure of arc SU is equal to 360 minus 70 minus 140. Okay. So we just subtract from 360, 70, that's 290. 290 minus 100 is 190. 190 minus 40 is 150. So arc SU would be what, 150 degrees. Okay, so I did that. So what did I need to know to make that problem go? What did I need to know in order to get it off the ground, right? If we were to put it into words, we might say all arcs added together equal 360. Add it up, equal 360 degrees. Okay, so that there, ladies and gentlemen, would be how to solve these, and that would be putting into words what it is a person would need to know in order to get this problem rolling. Okay, let's look at another example, this time one involving the central angle. So I'm going to erase that so that I can move the problems along and have a fresh screen. There we go. This is problem number 4. What is the measure of angle QTR? What is the measure of angle QTR? Notice the T is the letter in the middle. So that indicates it is the vertex. It is the corner of the angle. There's the T. It's at the center of the circle. So when the vertex of an angle, when the corner of an angle is at the center of the circle, that angle is a central angle. And like you saw with the clock, 3 o'clock, 90 degrees equals 90 degrees of arc. Whatever the measure of this arc is, RQ, it would equal the central angle. So knowing that would help us to solve the problem. Also note that, right, all the central angles added together would equal 360. So solve it that way. So the measure of angle Q T R equals 360 again, minus 130 minus 110. So the measure angle QTR would equal 360 minus 130. 360 minus 100 is 260. Minus 30 is 230. Minus 100 is 130. Minus 10, 120. So the measure of this central angle is 120 degrees. And to make sure it's correct, you could add all the angles together, make sure they equal 360 degrees. 100, 200, 300, 30 and 10 is 40, 40 and 20 is 60, 360. So that'll work. What do we need to know to make this problem go? We need to know that all central angles added together, added up, added up, equal 360, right? 360 degrees, bing. And that's what allows us to place that there, right? Knowing that gets the problem rolling, okay? All right, let's look at a couple more problems, and you can get onto the IXL that this practice is going to help you to do. Excuse me. What if the problems ask, what is the value of X? Let me finish erasing for you. What is the value of X? Well, we'll take our central angles here, right? Now we've just got to see them and recognize, hey, we're dealing with central angles. And that being the case, if we add them all together, they must equal 360. So I could use the 360 and let it equal X plus 55, X plus 55 degrees plus 2X plus 2X, right? Those three central angles must add up to 360 degrees. Now we combined what can be combined. We can combine X's, we can combine X's with X's and numbers with numbers, but we can't combine X's and numbers. No. So we'd have to do X plus 2X is 3X plus 2X is 5X. And we just have the number there, 55 degrees. So there we go, plus 55 degrees. There. So 360 now equals 5X plus 55 degrees. Getting this equation shaved down to where it just equals X. Well, a good step to take at this point would be to subtract 55 from both sides. After all, 5X plus 55 minus 55 leaves us with just 5X, while 360 minus 55 equals 305. Yeah, 305. Now we divide 5X by 5, 305 by 5, leaving us with X. So 5 into 30 goes 6, 5 into 5 goes 1. So it looks like X equals 61. Once again, asking ourselves, what do we need to know to get this problem off the ground? Might say, similar to what we said before, all central angles added up equal 360. Okay, let's look at one more problem after we finish noting that in this box here. Okay. Okay. So that one deals with the central angles. Maybe there's one where there's some X's and some arcs, some X's and some arcs. There we are. Problem number 10. So got that thing right there. What is the value of X? All right, all the arcs added together must equal 360 degrees. So I can roll with that. And 360 must equal X plus 49 degrees plus X plus 10 degrees plus X plus 37 degrees. See, all those arc measurements must add up to 360. So we add them all up, set them equal to 360. Now we can combine what can be combined, the X's with the X's, the numbers with the numbers, X plus X plus X. There we have 3X. 49 and 10 is 59. 59 and 30 is 89. And 7 is 96. So looks like 360 degrees equals 3X plus 96 degrees. So we want to solve for X. So I want to break this thing down step at a time. So this final equation will read X equals whatever it turns out to be. So subtract 96 from both sides. 360 minus 100 is 260. So minus 96 must be 264, right? 264 equals 3X. And then we divide the 3 into the 26. That's 8 times 3 is 24. So there's 8. And 2 left over. That puts the 2 in front of the 4, 24. And 3 goes into 24 8 times. 88 equals X. So now we know. If we want to check it, we can substitute the X into each one of these and make sure they all add up to 360. Once again, what do we say here to help us? What do we know here that helps us get this problem rolling? We know this, all the arcs. All arcs added up equal 360. Boom. So I hope that helps you understand how to solve for a central angle, an arc, or for the value of X. Good luck. You too, 80 or higher.